You know, for over a century, the moment you drove a new car off the lot was the absolute best it would ever be. From that point on, it just got older. But what if I told you that fundamental truth is being completely torn up and rewritten? Your vehicle isn't just a static machine anymore, it's an evolving piece of technology, a lot like the smartphone in your pocket. And this incredible transformation is all powered by something called over-the-air or OTA updates. Seriously, just think about that for a second. What if your car could actually get better over time? Imagine waking up one morning and poof, it's safer, it's more efficient, or it suddenly has a cool new feature that wasn't there when you went to bed. This isn't some far-off science fiction dream, it is happening right now. Today, we're going to break down exactly how this tech works, why it's a complete revolution for the auto industry, and maybe most importantly, how it's all done securely. Okay, so to really get why this is such a huge deal, you gotta look at how things used to be. I mean, not that long ago, if there was a software bug, or heaven forbid you wanted a new feature, that meant a trip, a physical trip to the dealership. It was a massive pain for you, and honestly, a logistical nightmare for the car maker. Right, so the old way was this whole song and dance of scheduling appointments, finding a ride, maybe losing your car for the entire day. The new way? Well, the update just downloads automatically, probably while you're asleep. And for the car companies, it's a total game changer. Instead of spending millions on physical recalls for a software glitch, they can just push a fix remotely. It turns vehicle maintenance from this clunky, annoying process into something completely seamless and digital. And this is exactly why automakers are jumping on this so fast. For them, it means they can get new features out to you almost instantly. It means they can keep improving the car you already own, which, let's be honest, makes for much happier customers. And when you're talking about millions of vehicles all over the world, this is the only way to manage it all. OTA isn't just a cool feature anymore, it's an absolutely essential part of any modern car. But making this all seem so effortless brings up a major technical challenge: the sheer size of the data. Modern car software is gigantic. We're talking millions and millions of lines of code. Trying to send that full update to a whole fleet of cars over a cell network would be ridiculously slow and cost a fortune. So, how do you get around that massive data bottleneck? Well, the solution is a really clever technique called delta compression. Instead of sending the entire software package every single time, you only send the changes, the deltas, between the old version and the new one. It's kind of like when you edit a document online. You don't have to re-download the whole thing, you just got the little bits that changed. This right here is the secret sauce that makes large-scale OTA updates even possible. And the results are, well, they're just stunning. Take a look at these numbers. A full update might be, say, 120 megabytes, but the Delta update, the one with only the necessary changes, get this, just 8 megabytes. That's a reduction of over 90%. Now, multiply that data savings by millions of vehicles, and you're talking about an absolutely massive drop in cost and network traffic. It's huge. Alright, so we've made the updates small and efficient, but now we have to talk about the biggest, most critical piece of the puzzle: security. I mean, if a car company can send a legit update to your car, what's to stop a hacker from sending their own fake one and taking control? This is the central problem that absolutely has to be solved, no exceptions. And let's be crystal clear, the threat is very, very real. The security standards that protect these systems are built around this exact worst-case scenario. A simple setup where all the updates come from one single server is just way too risky. If that one place gets compromised, the entire fleet of cars is vulnerable. And that brings us to the core principle of modern OTA security: compromise resilience. The whole idea is to build a system that stays safe, even if one part of it gets hacked. And the golden rule is you never, ever trust a single source of information. So to pull this off, security frameworks split the job across two totally independent servers. It's like needing two separate keys held by two different people to open a high-security vault. So the first key is what's called the image repository. The easiest way to think about this is like a giant, super secure master library. It's a server that holds a perfect copy of every approved software update the manufacturer has ever made. It has the what, the actual files, but, and this is crucial, it has zero idea which car is supposed to get which file. The second key is the director repository. Now, if the first one is the library, this one is your trusted personal advisor. It's a highly secure service that keeps a detailed list of every single vehicle. It knows exactly what software your specific car should have, so it creates these unique, digitally signed instruction lists for each car, telling it precisely what to go grab from that master library. It's got the who and the how. Okay, so here's how these two keys work together in this beautiful little security dance. First, your car reports its current status to the director. Then, the director creates that unique signed instruction list just for your car and sends it over. Only then does your car go and download the software from the image repository, but it will not install a single thing until it confirms that the files it got perfectly match the signed instructions from the director. An attacker would have to compromise both of these separate systems at the same time to pull anything off. That is what we call resilience by design. So, with that rock-solid secure foundation in place, we can finally get back to the really exciting part, the future that OTA updates make possible. See, this was never just about fixing bugs. It's about fundamentally changing the car from a one-time purchase into something that provides a continuous service. And this is what brings us to the age of the software-defined vehicle, or SDV. What that means is that a car's features and its abilities are primarily controlled by software, not by fixed hardware. So the car that rolls out of the factory isn't the finished product anymore. Nope, it's a dynamic platform that can be upgraded and even reconfigured for its entire life. So what does that actually mean for you, the driver? Well, how about this? Imagine subscribing to heated seats just for the winter. Or what if you could get a performance boost, more horsepower, better EV battery range, delivered to your car overnight with a software patch? And think about the critical stuff, like instantly fixing a newly discovered security flaw on millions of cars at once. Your car basically becomes a canvas for new features, delivered on demand. As this technology becomes the new normal, the very idea of what a car is evolving right in front of us. It's not just about horsepower and handling anymore. It's about processing power and connectivity. The car is becoming a service, not just a product. So I'll leave you with this final thought. If you could download any new feature for your car right now, tonight, what would be the first thing you choose?